Understand what a thin layer chromatography is. Obviously, it is, you must have studied in your O levels thin layer chromatography as a separating technique, but it is rather an analytical technique. और से देखो कि the things that we need to focus on in O levels, you studied paper chromatography, is that right? यहाँ पर उसको थोड़ा जरा broader vision में we'll take it. There has to be a stationary phase and there has to be a mobile phase in thin layer chromatography. So yeah, what is the stationary phase? Stationary phase is supposed to be a solid or a liquid which is supported on a solid, kind of like a gel kind of thing. So yeah, and mobile phase is the phase that will take the components through to the stationary phase. Stationary phase, it is the solid phase जो अपनी जगह पे रहता है, but stays, the word suggests stationary phase. For example, I know it's not the right example, but in O levels, your paper is supposed to be the stationary phase. And the solvent which travels up the paper, that solvent is supposed to be the mobile phase. The components travel with the solvents on to the stationary phase. Is this clear? इसको लिख लो जरा पहले understand, क्योंकि the question often asks you what a stationary phase and what a mobile phase is. Stationary phase can be your aluminum oxide, which is supported on a solid. Your syllabus specifically mentions aluminum oxide, so you write it particularly. And a mobile phase is mostly a solvent, and which can either be a polar solvent or a non-polar solvent. Example दिया मैंने, पेपर नहीं होता हमारे thin layer. This is not paper chromatography. This is the thin layer chromatography. But you can relate it with paper chromatography. TLC प्लेट के ऊपर एल्यूमिनियम ऑक्साइड लगाया जाता है हमारे पास, सही है ना, which is the सिलिका जेल भी लगाया जाता है कभी-कभी। नहीं, the components move through the stationary phase. Stationary phase खुद नहीं हिलता।
तो इसमें the solvent is the stationary.
No.
Mobile phase.
Mobile phase moves through the stationary phase.
Right.
It carries the components through the stationary phase. Stationary phase, the phase वो खुद तो stationary रहता है, but उसके ऊपर
definition क्या है? आपने बोला ना पूछने की definition क्या है?
हाँ, तो यही पूछते हैं, स्टेशन phase जिसके through mobile phase moves out the components that you need to analyze move through the stationary phase. The phase is a solid or a liquid supported on a solid. Is this clear?
Liquid or solid or gas?
क्या?
आपने बोला ना
लिखा है ना सामने बच्चे.
solid or gas? Solid or liquid supported on.
So this is common for all kinds of thin layer chromatographies. Is this clear? This clear? इसमें हमारे पास specifically in a thin layer chromatography, what is a solid or a stationary phase? Aluminum oxide, right? It's specifically लिखो. Aluminum oxide on a solid support is our stationary phase.
तो mobile phase ये जो लिखी है वो इस वाले.
Yes. Is this clear? Now what basically happens, the solvent starts to travel up. Okay, the solvent starts to travel up, and there is a particular point till which the solvent travels. I'll give you an example for this as well. Example there. Take a paper and dip it in water. Just dip it in water. What happens? What do you see? What does the water do? It travels up the paper, doesn't it? So that is something that you can use to visualize this, that the mobile phase travels up the stationary phase और एक point तक जाके solvent रुक जाता है. हो सकता है कि when you dip a paper in, your entire paper doesn't get wet, does it? But the water travels up till a certain level. Similarly, the solvent travels up the stationary phase to a certain level. So that is a level जहां तक solvent हमारा travel करता है. उससे हम मेजर करते हैं, वी कैन मेजर द डिस्टेंस ट्रैवल्ड बाय द सॉल्वेंट. जहां से सॉल्वेंट हमने स्टार्ट किया, जहां हमने कंपोनेंट्स लगाए हैं, दैट इज द स्टार्टिंग पॉइंट, और वहां से वी सी के कहाँ तक हमारा सॉल्वेंट ट्रैवल कर रहा है, दैट इज द डिस्टेंस ट्रैवल्ड बाय द सॉल्वेंट. ये डाइज या कंपोनेंट्स हो सकते हैं हमारे पास. दिस इमेज शोज यू डाइज, but these can be any particular component. Now what is an RF value? An RF value is the distance traveled by the component divided by distance traveled by the solid. Is this clear? So obviously, नहीं, RF value simply यही होता है. It is the distance traveled by the component divided by distance traveled by the solvent. Obviously हमेशा decimal में आएगा ये. With particular solvents at particular temperature, particular components will have fixed RF values. प्योर कंपोनेंट्स, फॉर एग्जांपल, बहुत वेग एग्जांपल दे रहा हूं, अगर आप कहें कि भाई सॉल्वेंट ए है और उसके साथ ये पर्टिकुलर कंपोनेंट एक्स है एंड द टेम्परेचर विच आई सेट और स्टेशनरी फेज बता दिया यही था, तो ये वाला जो कंपोनेंट एक्स है इसकी आरएफ वैल्यू. अब नो मैटर इन विच पार्ट ऑफ द वर्ल्ड यू आर परफॉर्मिंग दिस टीएलसी, और मैं कहीं और परफॉर्म कर रहा हूं, बट इफ आई हैव द सेम सेटिंग्स, माय सेम कंपोनेंट विल टेक सेम आरएफ वैल्यू. Is this clear? बिल्कुल, it is used to recognize component. यही तो कह रहा हूँ, if a particular
example, different condition है.
तो RF वैल्यू चेंज हो सकती है.
तो अगर RF value change हो सकती है, तो हम कैसे
उस कंडीशंस के हिसाब से RF वैल्यू देते हैं. और मॉडर्न डेज में तो ये वाली क्रोमेटोग्राफीज कम यूज होती हैं, इनका एनालिसिस भी इज डन मोस्टली थ्रू कंप्यूटर्स. मॉडर्न डेज में तो सारा काम ही कंप्यूटर एनालिसिस करके आपको देता है. एंड दिस इज नो नॉट द ओनली वे टू अंडरस्टैंड और एनालाइज योर substance. You do more tests, आपको और analytical techniques होती हैं, सबको combine करके and then you realize okay भाई, now this is what I'm supposed to have. So सिर्फ एक analytical technique से हम rely नहीं करते. Is this clear? Anything that is not clear up till this point? सही है. What is a baseline and what is a solvent front? बताओ.
इसके ऊपर components रखते हैं.
Very good. Baseline is the line जिसपे हम components रखते हैं इसमें. This is our baseline. And what is the solvent front? Someone asked us to label the solvent front. This is our solvent front.
जब distance travel by solvent के end तो इसकी distribution क्या है?
क्या मतलब? सॉरी,
हमने बोला solvent front की definition क्या है?
solvent front is the level at which till which the solvent travels on the stationary phase, or the level at till which the mobile phase travels on the stationary phase. सही है. Okay, now we need to understand one more thing. RF वैल्यू किस किस चीज पे डिपेंड करती है? किस बच्चों? बोलो बोलो बोलो. Type of solvent. Yes, you're right. RF value depends on the type of solvent. And
Okay. Component of the factor.
if I were to simplify it, I'll say that the RF value it depends on two things. पहला है interaction with the stationary phase. Write it down. And second is solubility in the mobile phase. What do I mean interaction with the stationary phase? How quickly does a particular component sticks on the stationary phase? And why will it stick on the stationary phase? Due to different intermolecular attractions. Same reason that the component is soluble in the mobile phase, for similar reasons, it might stick onto the stationary phase. तो दोनों चीजों को अलग अलग देखते हैं. The stronger the interaction between a component and the stationary phase, what will happen to the component? Will it go farther up or will it travel very short distances? पहले जवाब दो. The stronger the interaction of a particular component with the stationary phase, the shorter the distance, and the more soluble the component is in the mobile phase, the farther up it will travel. Is that right? Now related to the RF values, the stronger the interaction with the stationary phase, the smaller the RF values. इसको लिख लो. The stronger the interaction of a particular component with the stationary phase, the smaller the RF values, because the distance traveled by the component will be lower. Similarly, the greater the solubility in the mobile phase, क्या होगा? What will happen to the RF value? The greater the solubility of the component in the mobile phase, the higher the RF value, क्योंकि वो फिर और आगे तक travel करेगा. Is this clear? बहुत odd और vague example दूंगा, but yes, it is a common observation. When someone sweats a lot, और एक खास तौर से cotton के, if you're wearing cotton clothes and if you sweat a lot, and when that sweat dries up, what do you see? Salt patches नजर आते हैं आपको अपने clothes पे? देखिए कभी salt के patches नजर आते हैं शायद? Yes, white color के नजर आते हैं salt patches. If someone exercises a lot, what happens? The salt with your sweat, it travels on your clothes to a certain extent, and when the sweat dries up, तो salt का patch आपको नजर आता है. So just to give you a reference कि how does soluble substances travel with a particular thing that they are dissolved in. So the mobile phase, उसके अंदर different components have different solubility, so they travel with the mobile phase. एक जगह पे जाकर, depending on their interaction with the stationary phase, they get stuck on a particular point, वहां पर जाकर रुक जाते हैं, and the solvent travels up to the solvent front. Is this clear? So just giving you a relevance कि चीजें soluble जब होती हैं तो they travel with a particular thing. Is this clear?